Hello guys. Am I audible? Am I visible? Let me know if everything is alright. Hello guys. Am I audible? Am I visible? Okay, so if you're watching this is our new channel exclusively for the English language students. So we have our main channel Physics. There we are basically trying to take the session in Hindi and English mixed. But here in this channel we'll try to keep the lecture completely in English. And we are starting from mathematical physics today. We are starting from the very basic. So we'll try to cover the course in detail. So here we'll be taking detailed course which will be helpful for your upcoming CSIR-NET examination. Today's first lecture title is dimension analysis. You know, the mathematical methods of physics starts with dimension analysis, so we are starting from that. And guys, you can download the Physics Hub application from scanning this QR code, and you can also join our Telegram Physics Hub 111. All the links are given in the description, and if you're new to this channel, please subscribe the channel so that you get regular notifications. Now, without any further ado, in the chat you can say whatever if any problem if you face. Okay, so CSIR-NET Physical Science syllabus, you know, for each subject there are two parts. One is this core part, another one is this advanced part. Okay, from core part we generally expect a 3.5 marks question. 5 marks question may also come, and from advanced part mainly 5 marks questions are expected. Now if you look at the mathematical methods of physics syllabus, you see it is not so much advanced. Like if I say 80% of the topics are easy to moderate, and for the remaining 20% you need to struggle really hard. This is we can consider to be difficult, but don't worry, if you can cover 80% efficiently, then the remaining 20% can also be covered efficiently, so that it will be covered in such a way that you can answer questions in your CSIR-NET examination. So you see, it starts with dimension analysis, which we will start today. We'll try to cover the whole dimension analysis in one lecture. Look, what will be my approach? Here my approach will be basically, initially will be mainly focusing on theory. Okay, theory, then mathematical derivation if you have mathematical derivation or formulae in the initial part, and later on I will try to share some assignment based on the topic. And while considering the theory, let's say I am explaining a topic, I am giving you all the mathematical formula, then we will also solve one or two problems, not more, one or two, so that you can understand how to utilize the mathematical formula or theory. And a dedicated practice session will be conducted in the form of assignment for the same. Okay, so broadly let's classify the syllabus. Firstly, it starts with dimension analysis, then we have a broader area of vector algebra, vector calculus. This is another chapter you can say. Then linear algebra, matrices, Cayley-Hamilton theorem, eigenvalue, eigenvectors. Up to this, all of this can be considered as the topic of matrices. Then we'll go for the linear differential equations, ODE, first order, second order, and it will also include Cauchy-Euler differential equation, all those forms. So we'll try to discuss each type, and we'll also try to take some example. Then 4 special functions are there. These are very important: Hermite, Bessel, Logier and Legendre. These are also very easy topics. After that, another topic is Fourier series. Fourier series is a standalone topic. Then Fourier transform, another topic. Laplace transform, another topic. After that, a big topic of complex analysis are there. In complex analysis, lot of things we have to know, the basic or fundamentals of complex analysis. Then you have to take the idea of analytic functions. Then some series expansion, which will mainly involve Taylor series expansion and Lorentz series expansion. Then look, from complex analysis, question can be framed different types. One type, from the basic elementary idea of complex analysis, analyticity of the function, checking analytics, whether this function is analytic or not. They will be giving you some unknown constant involving the analytic functions. They may ask you to find out the value of the analytic functions. Then another type of problem can be set from the series expansion, Taylor series, Lorentz series, all those things. Then a major portion will be here, evaluating the poles and residue using Cauchy residue theorem, evaluation of integral. Look, this evaluation of integral, although it is mentioned in only few words, but you have to type different types of integrals. Okay. After that, probability theory, random variables, probability distribution and central limit theorem. So in the core part, the syllabus you see is very basic. We can cover it in few days. Okay, if you are only covering theory and little bit of problem, but you see maximum problem, if you consider all the 9 units of CSIR-NET, maximum problem you get to see from mathematical methods of physics, because these are mathematics. You can create lot of hundreds of questions from this. You just change few values, change some condition, and you get a new problem. So once you understand the basics of all these topics, you are ready to go with the problems. Whatever complicated problems you are given, you will be able to do that first. But before that, you have to strengthen your theory. In the advanced part, you see Green's function. This topic is generally advanced topic and little bit difficult, but what is needed for your CSIR-NET exam, that we can tackle very efficiently. Okay, so you don't need to waste too much time in going very deep into the subject. For CSIR-NET, you make a target to complete the whole syllabus in 6 months. 6 months is more than sufficient to qualify JRF. And it is not like you are only doing short notes and from the surface. Even you take up the mid-up approach, you can cover the syllabus efficiently and you can get a good rank. Then PDE, partial differential equation. This is a little bit difficult topic. Laplace, wave and heat equations. So these are basically gives you complicated expressions, lengthy solutions. So you have to consider in 2D and 3D. So don't worry, I have arranged them in a very simplified manner, so it will be covered. Then numerical analysis. This is your plus point. Numerical analysis in general, you are given easy problems, so you can easily deal them in the examination. So root finding methods, bisections and all those things, Newton option, some methods like that, we will talk about that. Then interpolation, Indian interpolation, we have Newton's forward interpolation, backward interpolation, Lagrange interpolation, all those things. Extrapolation means when you are considering out of the table. Like let's say you are given the 10 values and you want to know the 11th value, 12th value, that is called extrapolation. And if you are given, let's say 1 to 10, you want to find a value in 5, 6 or 7, something like that, then that is called interpolation. Then some numerical integration based on trapezoidal and Simpson's rule. After that, solving of differential equation using this Runge-Kutta method, Runge-Kutta second order, Runge-Kutta fourth order, all those things. Finite difference method, this is a very good method. So we have to cover them. Okay, we should not leave any topic. If you are not able to cover any topic deeply or in a good manner, you have to just cover it from the surface at least, but you should not leave any topic uncovered. Then tensors and group theory. So these topics can be covered from the surface, because these topics are core mathematical topic. So if you want to learn them, you can learn them, but that will be like core topics of mathematics. But we are physics students, so we will be covering up to that amount which are required to qualify the CSIR-NET examination. Okay. Let's move on. So this is about the syllabus. Now let's try to analyze. Once you know the syllabus, the next thing is like how many marks we can expect from this part. So some statistics you can see on your screen, marks distribution. So number 4th we have mathematical physics MP. You see in 2020 29 marks came, in 2021 25.5, 2022 37.5. so you can see this is a good weighted subject. You can expect around 25 to 31 average 25 to 30 marks. This is huge, and the good news is you can cover 100% of the mathematical methods. Okay, if not 100%, 90% can be easily done if you have covered everything. If you are a little bit if you are good enough student, you can easily cover 90%, and sometimes all the question can also be attempted. So this is a very scoring subject. Scoring subject is basically fundamental subject which is required to cover other subjects as well. So you should definitely start with this subject, mathematical physics. If you are starting your preparation for CSIR-NET examination, the first subject should be the mathematical physics subjects, then quantum mechanics. These two subjects are the subjects to start with. Okay. Without any further ado, let's start with the discussion. So as you know, we'll cover today the dimension analysis. So very easy topic, will not take much time. So without any delay, let's start. And let me tell you this dimension analysis, why this is important, because it helps you to solve problems without actually solving the problem. By comparing the dimension, you can easily answer some of the questions if some trick is not involved in the question. So we quantify the size and shape of things using dimension analysis. It basically helps us to study the nature of the object mathematically. And what is the basic concept of dimension? It is that we can add, this one line is very important, we can add and subtract only those quantities that have the same dimension. Okay, we can add 5 apples to 5 apples, or 9 bananas to 4 bananas, but we cannot add 5 apples to 4 bananas. So if you want to add something, the quantities should be of same nature, otherwise you cannot add. So that is the basic of dimension analysis. The study of the relationship between physical quantities with the help of dimension and units of measurement is termed as dimension analysis. The overall process is known as dimension analysis. Why it is essential? Because it keeps the unit same. This one is the ultimate thing. It keeps the unit same, helping us to perform mathematical calculation smoothly. So this is the qualitative idea. Let's go a little bit deeper, and before that, these symbols are very necessary. You know, these symbols you will be using throughout your preparation in other subjects as well. So these units I have given you in one single table, so you can also note down this table. You see here lot of units are there. There are big units, there are small units. So where to start? Let's say let's cover the small unit first. So if you consider this is a 0 unit, it's a meter. Okay, 1 meter, 10 to the power 0. If you're coming back, 10 to the power minus 1. So this becomes deci. decimeter or something. So to the power 0 you can select as base meter. A meter basically gives you the dimension of length. Okay, it is corresponding to length, but these units can be used to quantify other things also. It is not length if it is about the mass or volume. Okay, so if you take the 0 line, 10 to the power 0, this is the reference. If you coming down one step below, that gives you deci. 2 step, 10 to the power minus 2, 10 to the power minus 2, that is centi. 10 to the power minus 3, this gives you, this unit is milli, denoted by small m, and if you are applying it to some length, it becomes millimeter. Okay, I am writing it here, milli. This is the basic symbol. If you add meter or unit of length, it becomes millimeter. Okay, if you write the unit of, let's say, Kelvin, millikelvin, then 10 to the minus 6, that is micro, 10 to the minus 9 nano, 10 to the minus 12 pico. So mainly these three units are popularly or widely used: pico, nano and micro. Femto is used in nuclear physics, 10 to the minus 15, and you can see the symbol m mu n p f. F is femto. Then these units are not used, but you should know being a physics student. 10 to the minus 18, this gives you auto. 10 to the minus 21 zepto. 10 to the minus 24 yocto, denoted by these symbols y, z, a. And if I talk about the big units, like this was 10 to the power 0 basic line, so you will go up one step, that gives you 10 to the power 1. If you go up another step, 10 to the power 2. If you go up another step, 10 to the power 3, and so on. So 10 to the power 1 is deca, so 10 to the minus 1 deci, 10 to the power plus 1 deca, 10 to the minus 2 centi, 10 to the power plus 2 hecto. 10 to the power 3, you know, kilo, this is widely used, this 3 is widely used. These 3 here on this side and these 3 here on that side. These 6 are widely used: kilo, mega, giga. Kilo is small k, mega capital M, giga capital G. So these units are, these symbols are very crucial to remember. Okay. Then tera, 10 to the power 12 is tera, 10 to the power 15 is peta, 10 to the power 18 is exa, 10 to the power 21 is zeta, 10 to the power 24 iota. So these are basically, I think, taken from Greek alphabets and Greek things. Okay. So for the time being, what you definitely remember from this 10 to the power 3 kilo, mega, giga, tera, up at least this 4 should be remembered definitely for sure. And on this side, 10 to the minus 15, 10 to the minus 12, 10 to the minus 9, 10 to the minus 6, 10 to the minus 3. This. So these things you will be using widely in your upcoming syllabus. So these things you need to keep in mind. Okay, let's move on. What are the applications of dimension analysis? It is basically a fundamental aspect of measurement and applied to in real life physics. So mainly 4 things we need to cover in the dimension analysis topic, the 4 applications. So questions may come from this 4. Other than this 4, there is nothing. I think this 4 is sufficient. First of all, to check the consistency of a dimensional equation. This is most widely asked topic, to check the consistency of a dimensional equation. Next thing is to find dimension of physical constant or coefficient. So in one dimensional equation, if one quantity is unknown, using the method of dimension analysis you can find out that unknown constant or coefficient. Third type is to derive the relationship between physical quantities and physical phenomena. Okay. For example, let's say you want to find out the time period of a simple pendulum. Now you know the time period may depend on the length of the string, mass of the pendulum, and acceleration due to gravity, but you do not know exactly in which way they depend, whether it is proportional or it is proportional to the square or it is proportional to the reciprocal of root or root, you do not know. So dimension analysis gives you the idea to find out the relation between different physical quantities. And fourthly, to change units from one system to another. You can convert your values from CGS to SI or SI to CGS or SI to FPS and all those things. So interconversion between different units are possible using dimension analysis. So we'll talk about these four things one by one by taking one example, one or two examples. So the first one, to check the consistency of a dimensional equation. It deals with homogeneity principle of dimension analysis. This one is very important. Principle of homogeneity. What is principle of homogeneity? It basically states that dimension of each of the terms of a dimensional equation on both sides should be the same, right? So if x is equals to this is an equation, you see on the left hand side only one quantity is there, on the right hand side we have a, it may be plus or it may be minus, whatever it is. It will not be multiplication or division, it will be plus or minus only, because you see. So if it is written in this way, plus 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 or plus minus plus in this way, then dimension of each term will be same. So dimension of x will be same as dimension of a, will be same as dimension of bc square, and dimension of root over def. You can see. And dimension you write in this way, within third bracket. I am going to write the dimension of x, we will write dimension of x. If x denotes length, then we will write it as length. If let's say x denotes time, we will write in this way. Remember this thing, mass, length and time, these are fundamental units. If the dimension of each term on the both sides are the same, the equation is dimensionally correct. Otherwise not. And ये बात देखो, this statement is crucial. A dimensionally correct equation may or may not be physically correct. Okay, but a physically correct equation must be dimensionally correct. So you need to understand the difference. Now let's check an application of this homogeneity principle. You can consider this problem. What is given to us? The velocity v of a particle at time t is given by this. What are the dimensions of a, b and c? कैसे करोगे इसको? देखो, this problem can be solved step by step. V is equal to 80. I am doing the solution here. V is equals to 80 plus B by T plus C. One thing you remember, one thing you notice, it is T plus C. So obviously, as I told you, you can add only similar quantities. So T is time, which has dimension T, and if you see a plus addition, so obviously the dimension of C, we can write dimension of T, obviously we can write, and dimension of AT, what will be the dimension of AT? Dimension of AT should be the dimension of velocity. What is the dimension of velocity? LT inverse. So from here you can find out the dimension of A. LT inverse divided by T. Okay, LT inverse divided by T. So it becomes LT to the power minus 2. So C is evaluated, A is evaluated, only B is left. So B by T plus C, this should be the LT inverse. Okay, now numerator dimension of b, and you know t plus c has the dimension t, and each quantity has dimension LT inverse. Each term has dimension LT inverse. So if you equate them, then you get the dimension of b. So LT inverse into t, the dimension of b becomes L. Okay, C, A and B. A is LT minus 2, B is L, C is T. So option B is coming out to be correct. So this is the first application of dimension analysis. The second one is to find the dimension of physical constant or coefficient. Let's check this one. To find dimension of physical constant or coefficient, let's take few example. The first example we are taking, let's say we want to calculate the dimension of gravitational constant. So how can we find out the dimension of gravitational constant? From Newton's law of gravitation, what do you know? From Newton's law of gravitation, we know this relation F is equals to g times m1 m2 divided by r square. So if you want to calculate the dimension of g, we need to find out g. G becomes f r square divided by m1 m2. So you see how we can find out the dimension of unknown constant g. So this will be dimension of f. We know the dimension of f, mlt to the power minus 2, dimension of r square divided by m1 m2, so m square. And you see this we get m inverse L cube t to the power minus 2. So using dimension analysis, we can easily find out the unknown physical constant, dimension of physical constant. Let's say next take another one, we find out Planck's constant. Planck's constant. What you need an equation involving that constant. So the equation involving Planck's constant is E equals to h nu, simple. We need h, so h equals to E by nu. So dimension of h will be dimension of E divided by dimension of nu. What is dimension of E? Dimension of E is dimension of work done, that is force time displacement. Force is ml to the power minus 2, displacement another one. Nu, it has unit time inverse. Okay, so you get ml square t to the power minus 1. So in this way you can find out the unknown constants. One example let's take from the CSIR-NET examination which came based on this. Look at this example. Using dimension analysis, Planck defined a characteristic temperature Tp from powers of gravitational constant, Planck's constant, Boltzmann constant and speed of light. The expression for Tp is. So to solve this equation, to solve this question, we should definitely know the dimension of g, dimension of h, dimension of Boltzmann constant, dimension of light, speed of light. Give me a moment. Okay, so dimension of g and h we have already evaluated. From E equals to h nu, we got the dimension of h. I am not repeating because we have all just evaluated. So dimension of H, what you got in the last slide, ml square T inverse. So I am writing directly, or you can evaluate. Dimension of G, dimension of G we have already got m inverse L cube T to the power minus 2, m inverse L cube T to the power minus 2. We did not find out the dimension of KB. KB, you know one relation, E is equals to KT, KBT. So from this we can get the dimension of KB, that is dimension of E and dimension of T. Dimension of E is ml square T to the power minus 2, and what is the dimension of T? T is given to be TP. Okay, let's say that is denoted by TP. You should write it in a third bracket to denote the dimension. So m L square T to the power minus 2 TP inverse. Okay, then we need to find out the dimension of C. C is finding very speed of light, LT inverse. Okay, so what will be the expression of TP? One way you can do, you can find out the expression of, let's say you take the multiplication of HC to the power 5 and you do KB square by G and you evaluate. Okay, and what, in whichever case you get TP, that will be the answer. Let's start with the first one, HC to the power 5 by KB square into G. HC to the power 5 divided by KB square into G. So H you have already calculated, ml square T inverse. Let's put the values. C is LT inverse. So you see, C to the power 5 means L to the power 5 to the power minus 5. KB square. KB is this m L square T inverse to the power minus 2 TP inverse. So you just make square of it. So m square L to the power 4, m square L to the power 4 T to the power minus 4 TP to the power minus 2. Okay, and G is already, you know, m inverse L cube T to the power minus 2. Right? So you see, the best way, you collect the coefficient of m, the power of m. M is 1, L 2 plus 5 7, T minus 1 minus 5 minus 6 divided by, collect the powers of m. 2 minus 1 1, L 4 3 7, T minus 4 minus 2 minus 6 and TP minus 2. So you see, this is nothing but TP square. So obviously if you take the square root, then it gives you the dimension of TP. So dimension of TP will be equals to the dimension of this quantity, right? So option A is found out to be correct. Clear? So this was the second application. The third application of dimension analysis, to derive the relation between physical quantities and physical phenomena. So if one knows the dependency of a physical quantity on the other quantities, and the dependency is the product type. The example I gave you, you know, that time period of a simple pendulum. You know that the time period has a relationship with the length of the string, mass of the pendulum, and maybe acceleration due to gravity, but we do not know the exact relation, let's say. So using the method of dimension analysis, we can find out the relation between the quantities. So for the time being, we'll use the dimension analysis to find out an expression for the time period of a simple pendulum. So in your examination, you may be asked to evaluate some other thing. They may give you the information that, let's say this quantity is depending on this. Then what will be the Using dimension analysis, find out the relation between this and this. Okay, so I'm giving you one example. So if I consider the time period of a simple pendulum, then on which factors it depends. So the time period of a simple pendulum may possibly depend upon the following factors. What are the factors? Let's say I am telling them, number one, that it may depend on mass of the bob. Mass of the bob. Let's draw the picture, then it will give you the clearer picture. Let's say this is the rigid support, and maybe, okay, let's draw. This is the vertical line, and the bob is situated here. Okay, it has mass m, and you can see this is the length of the string. So it is depending on mass of the string. And second thing you can see, visualize here, number 2, length of simple pendulum. It's called length of simple pendulum. Simple pendulum doesn't mean this bob only. The whole thing is simple pendulum, constitutes the simple pendulum. So length of simple pendulum means it is denoting this length of the string, L. And you can see, you cannot deny the gravity, right? So gravity is also acting here downward. So it may depend on the acceleration due to gravity. Acceleration due to gravity g, and it can also depend, you can see it may depends on the angle theta. So fourth factor may be angle of swing of pendulum, theta. So although we know now on which factor the time period is depending, but we do not know like the power of these factors. So let's say the time period is depending on mass. We do not know the power, so let's say it is A, length g, theta. So these are proportional to, you can say. Now if we just remove this proportionality sign, we can multiply some multiplicative constant. I am showing you one example and you have to tackle the others. I will give you one homework also. K is the dimensionality constant, or you can say K is constant of proportionality or proportional constant. Proportional constant. Now from a dimension analysis, you know, dimension of left side should be equals to dimension of right side. So using dimension analysis, we can say dimension of left hand side should be equals to dimension of right hand. This is constant of proportionality, proportional constant, so it doesn't have any dimension. So mass dimension m, length L, g is basically acceleration has the dimension L to the minus 2, theta theta is dimensionless, so we don't need to consider. Dimension theta is basically an angle that is dimensionless, right? So if you collect the coefficients, so it becomes m to the power a. I am not giving a third bracket for the time being. L to the power b plus c and t to the power minus 2c. So it should be equals to the dimension on the left hand side. Here you see you have only t to the power 1. It doesn't have m dimension of m and l. So m we can consider it is like 0. L is nothing or is 1. So L to the power 0. Now we can compare. We can equating the powers of m, l and t on both sides. You get, what do you get? We get a is equals to 0. This one is straightforward. B plus c equals to 0. That makes b is equals to minus c. Okay, and minus 2c equals to 1. That gives you c is equals to minus half. And from this we can write b is equals to plus half. So t becomes k L to the power half, okay, and g to the power minus half. Theta is dimensionless, so we don't need to cover. That is not appearing because d is equals to 0. Okay, so you get k root over L by g. So using dimension analysis, what extent we can go? We can go up to that extent that we can establish a relationship between the quantities T, L and G. So you see, this is the kind of relation these three quantities follows. But we are not able to find out the value of this dimensionless constant k. We know from experiment that the actual expression is 2 pi root over L by g. Right. So using dimension analysis, we can evaluate only t, the relation between t, l and g, but we cannot evaluate this value of 2 pi. So k is equals to 2 pi you cannot find out using dimension analysis. This is the shortcomings or the limitation of dimension analysis. We'll talk about it. Chalo. Now I'm giving you one example. So take this example as homework. I'm giving you as homework. You can set the homework in our WhatsApp group. The WhatsApp group link is given in the description. You can join newly opened WhatsApp group. You can join to get regular updates on the classes. Okay. So take this as homework. Similar problems. Here force of viscosity F acting on a spherical body moving through a fluid depends upon its velocity. So you can consider it like this. So a jar, something like this, a beaker like this. Anyways, you can imagine it in this way. Some fluid is there and you are dropping a spherical body. So this liquid will exert some force on the spherical body. So it is depending on velocity, radius of this and coefficient of viscosity eta of the fluid. So you can take it in this way: v to the power a, r to the power b, eta to the power c, and you can write k, v to the power a, r to the power b, eta to the power c. So using the dimension analysis, you have to find out the expression of f. Okay, so you can give it a try. You can find out the value take it as homework. And you know this this is a very famous equation, F is equals to 6 pi eta r b. So obviously option A will be the correct option, but using dimensional analysis try to evaluate this. Okay, now we are coming almost at the end of the applications of dimensional analysis. So three applications we have already told. The fourth one is quite easy and important. Okay, this one, fourth one. Look at this. The fourth application is to change units from one system to another. So let's say you are given a value in one system, you can change it to other. So measure of a physical quantity Nu is equals to constant. This one you need to understand. N is the numerical value, U is the unit, that is constant. So you can consider like the 1 kg equals to 1000 gram. So numerical value unit, numerical value unit. No, the product should be same. If a physical quantity X has dimensional formula MLT, and if the derived unit of physical quantity in two systems are M1 to the power A, L1 to the power B, T1 to the power C, and M2 to the power A, L2 to the power B, T to the power C, and N1, N2 be the numerical values, then N1 U1 is equals to N2 U2. N1 and N2, these are numbers, so that is why dimensional brackets are not given. U1, U2 are to be considered. Here you see 1 and 1000, we cannot do anything about 1 and 1000, but we can definitely do something for kg and gram. So this equation holds. N1 and the dimension of U1, you have to express it in this way. Dimension of U2, you have to express it in this way, and from that you can evaluate the value of N2. Okay, now N2 is equals to N1 M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C. Here I am just showing one example, but if you consider the derived unit, let's say a meter per second square, okay, or kg meter per second, that is why it is in general it is given. For this is the case of mass only, no? Here it is the case of mass and time. Here it is the case of mass, here it is length and time. Here it is mass, length and time. So for general purpose we will be utilizing this formula. M, L, T are fundamental units of mass, length and time in the first known system, and M, L, T are fundamental units, as I told you earlier. M, L, T are fundamental units of mass, length and time. Knowing the values of fundamental units, two systems, and numerical value in one system, the numerical value in other system can be evaluated. तो एक example ले लेते हैं. So the very famous example, let's say I want to convert 1 Newton into dyne. So conversion of Newton is a SI unit of force, to I want to convert it into CGS unit of force, that is dyne. We know the relationship. 1 Newton is equals to 10 to the power 5 dyne. So let's say how we can evaluate it using the method of dimensional analysis. So 1 Newton is nothing but 1 kg meter per second. ये तो होता है ना. And now using the formula, let's say N1 is the value in the SI unit and N2 is the value in CGS unit. ऐसा हम लोग consider करते हैं. So N2 is equals to N1 time, the formula is this, M1 by M2, L1 by L2, T1 by T2, you can see to the power ABC. M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C. So here N1 is 1, 1, M1 in SI unit, 1 denotes 1 for SI, 2 for CGS, right? So M1, what is M1 in SI unit? It is kg. Okay, meter second inverse. Okay, M, अच्छा 2 होगा ना, ml to the power -2. Okay, M2 gram, L2 centimeter, T2 here is second, and power it is A. What is the power of kg? It is 1. Power of B, meter length 1. Here it is -2. Okay, 1 kg is equals to 10 to the power 3 gram. 1 meter 10 to the power 2 centimeter, and this is contributing nothing. second 1. So 10 to the power 3 and 2 5. Okay, yeah, we are basically finding numerical value, so that is why it is 10 to the 5. All the units are cancelled out. So using this we can find out 1 Newton is equals to 10 to the power 5 time. So here in SI the thing was N1 numerical value and U1 is here kg meter per second square, and for this one numerical value is N2 and unit U2 is nothing but you can say gram centimeter second inverse, right? So in this way we can find out the conversion from one unit, one system to another. So we have covered all the 4 applications. I am telling you once again, these are the 4 applications. Firstly, to check the consistency of a dimensional equation. Second, to find dimension of physical constant or coefficient. Third, to find the relationship between physical quantities. Fourth, to change units from one system to another. So we have discussed all the 4 cases separately, and I hope you have understood, and from in the examination any of the 4 may come. Now last thing, what are the limitations of dimensional analysis? So we have seen lot of benefits of using the application of dimensional analysis. Now what are the limitations of dimensional analysis which we cannot do using dimensional analysis? So some of the limitations include, first of all, it does not give you the information about the dimensional constant. Okay, in the case of t is equals to k root over L by g, we could not find the value of this dimensional constant k. So this is one of the limitations. Second, the formula containing trigonometric functions, exponential functions, logarithmic function cannot be derived. So in one example we have seen that this t may depend on theta, but you see it will always be 1, right? Theta is dimensionless, and this exponential function, logarithmic function, these all are dimensionless. So if these things appear in particular equation, those things cannot be detected using dimensional analysis. So this is another limitation of dimensional analysis. Third, it gives no information about whether a physical quantity is scalar or vector. So nothing is mentioned about the about a quantity being scalar or vector. So these 3 are the basic or main limitations of dimensional analysis. So in one lecture we have covered the whole dimensional analysis, and I think now you got pretty well organized idea about dimensional analysis. So if you watch this lecture, I don't think you will be stuck in any problem in dealing with dimensional analysis problem. Irrespective of this, if you have any query, you can let me know in the comment section. If you are watching it recorded in a recorded form, you can write your questions in the comment section. I'll try to answer. You can try to watch live because it may not be always available. So this is all for this video, guys. See you tomorrow at 8 a.m. again. Thank you very much. And if you're new to this channel, please subscribe to the channel. Don't forget to press the bell icon.